Mrs. M. Priyadashni, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for Corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD, and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies, and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science Java Part 33. So till your previous sessions we were discussing about a few sample programs that is based on the concepts that is available in Java, and also about few control structures and so on. So here more in these two sessions, from this session and your next session, we are going to discuss about how GUI components are used in development of Java, and how do we make those components listen to various events, and how whenever we develop an application, how to handle all these components, how to place, how to organize and use these components effectively. So first we will look into how to access the screen size. Next we are going to see how to use font in applets, and then we are going to see how to add components in an applet, and then about grid bag layout and how to organize components using various layouts. So first we will move into accessing the screen size. So why do we need to access the screen size? So we have seen the basic difference between your AWT and Swing packages. AWT is a heavy weight component, and it is more particular to that of the platform on which that particular component is being created and run, whereas your Swing is lightweight components which is developed based on your AWT components. So your Swing is a wrapper on your AWT components. So these are lightweight components. And next what we have seen is, whenever I place the components on a particular screen size, and whenever I try to load the same application on different screen size, so if at all I am trying to use a particular layout, then we don't have any issues. But if I am using set layout to be null, I am not following any layout, and then I place the components by giving the XY position and the bounds, I am setting the bounds of that particular component, then in that case when my screen size differs, the components may not be placed in the same manner as they are placed in one particular screen size. So a few of the components may go beyond the screen size and so on. So in that case what we can do is we can access the screen size, and based on the screen size we can set the place of our components. That is, we are trying to relatively place our components based on the screen size. So in order to do this, accessing the screen size becomes important at certain point of time. So you can see here we have import java.awt.star package. So where we have classes such as your dimension and your toolkit and so on, which are used in order to access the screen size. So we have public class frame size demo. So I have a frame, and then I have a dimension which has X and Y position, and then in the constructor I am creating a new frame and making that to be visible. So next you can see here toolkit. So this is the class in which we have a method called get default toolkit, and inside that we have get screen size. So this get screen size method will get the current screen size, and this will be returned as an object of dimension. So once I receive this, I call the set size method and set the size of my frame to be the size of the screen. So here we have used in order to set the size of the frame to the screen size. So this is the maximal size of your screen for the frame. Whereas this screen size could also be, this toolkit could also be used in order to place all your components. So for example, I want to place the component at the center. So I can find the center position and then I can place my component there. Based on the screen size, I can organize my component. So left hand side, right hand side, wherever I want to place it, instead of directly specifying that particular position 20, 20 and so on, you can access the screen size. Based on the screen size, I can make the components, arrange the components and arrange all the components in the screen irrespective of whatever may be the screen size for which they have been designed. So you can see I can print the width and height of the particular dimension. Here is your main method where your constructor is called. So you can see here the output is not just a frame on your desktop. So it occupies your entire desktop area. So this is your taskbar and this particular frame which you have created occupies the entire desktop area, whereas normally our frame will occupy a part of your desktop. Whereas here, since I have acquired the screen size and then I am trying to place my particular frame with the entire dimension, it occupies your entire desktop. So like this you can access your screen size and place all your components with respect to the relative position of your screen size. So next is how to access font in applet. So we know what is the use of applet code. So applet code is a HTML code which could be accessed and run by your applet viewer, or else you can place this as an HTML file. Inside your HTML site, inside your body part, you can include this applet, and this applet will automatically include the class file or else execute the class file that is given us in the code. So here you can see here we have an applet. So we have two font objects. So this font objects are used to design what type of font is decided for a particular content. So here I have h1 is equal to new font. This is in init method. So in your initialization, I am initializing the two font. One is courier font.bold and then the size. Again I have another font class object where I have specified the font size to be Times New Roman, font italic and 20. So here you can see two different fonts. So this could be used inside your code, inside your applet, wherever you like, in order to specify. So for example, you may see in your HTML we have an option in order to specify heading 1 should be of this type and this size, and then when you go inside your subheadings, so normally the size and the font type differs. So here you can see paint method. So inside we have a graphics object, graphics.setFont. I am setting the font to h1. So h1 applies the information what you have applied to your font. So here draw string. So I am drawing a string UGC lecture series in Java, and then I am specifying the XY position. Again I am setting a font for the different font for my graphics object, and then I am trying to draw a string, and this string is positioned in this position. So you can see on executing this particular applet using applet viewer, you can visualize the applet. Here this and this has different font settings. This is F1 and this is your F2. So based on the positioning and based on the font size and font type, your display of your font happens. So whatever the contents that you display could be specified to your common font similar to that what we have in as CSS, cascading style sheet, in that of your HTML. So next is various components in the applet. So you know what are all the AWT components that is available. As I told you that in your applet you can have all your AWT components. So here we have text fields, design, loaded, and then buttons, your list, label, text area, and few checkboxes. So here in your init method, init is similar to that of your constructor, or while loading your applet, this init method is called, and it is only called once. So you can see here we have a label and we have a text field, and then here a text field is specified only with the field size. Here specified with the content, that is the text, and button with the caption that should be displayed on the button, then your text area 10 by 60. So here we have checkboxes. So one of the, if at all the checkboxes belong to a particular group, then one only could be set to true. Here standalone is a separate checkbox, and then your web is a separate checkbox. So it means that they never belong to a group. So they will act as just as a checkbox. Whereas here we have a checkbox group. So this will act as a radio button. So we have 3 checkboxes which could be organized in one particular group. So any one of them could be true at a point of time. So after your checkbox, so we have seen that we have labels, we have a list, and here we are trying to add the elements in the list. So now all the elements in the list are added, and then I am trying to add the list. Then I am trying to add the text box button. So you know that the default layout of applet is flow layout, and the components will be placed in the order in which they are added onto the applet. And once it reaches the maximum size of the applet, then the second row elements will be started, elements will be started to be placed in the second row. So next I keep on adding all these elements based on the size, and based on the size of the applet, and based on the size of the components, the elements will be organized. So here we have applet code, and you can see here now you have an applet being displayed with the text box and then your button that has been designed. And so here first we place these 3 components, and after we place these components, again we place another text area. So then your checkbox group, your list, and then again a text box. So here these components occupies your applet based on the size of the applet that you have fixed. And once you try to resize this particular applet, when this applet is getting resized, so all the components and the flow in which they have been added and the number of components in the particular row will be altered. So you can see whenever I try to resize this particular applet, so you can see all these components are placed in one particular row. So here, since this number of components could be accommodated in one particular row, we were able to accommodate this in one particular row. If you keep on resizing it, automatically the number of components that is available in that particular row could be increased or decreased based on the size of your applet. Next we will move into grid bag layout. So we have seen that we have various layout managers which decides upon how your contents is added. So normally in case of your applet, we have a default layout. In case of your frame also, we have a default layout. So flow layout is the default layout for an applet, we have already seen. And in case if you don't want that particular layout which is by default to be followed, so in that case we set that to be null and place components wherever we like. And if you are very particular about a particular fashion in which your components need to be added, then you can go in for such layouts. So we have basically seen flow layout where your elements are organized in the fashion they are added, and depending on the size of the container, your elements will be added to your next row, and number of rows and columns is purely dependent on the size. Whereas in case of your border layout, we can specify where exactly your components or container inside a container need to be added. So I can specify my east position, west, north or south or center. I can specify where exactly my components need to be placed. And I already told you that whenever I add the component could be placed on a container, and the container could again be placed on a particular container. So in that case, whenever I resize the particular, so for example, I am resizing my applet. If I would have placed a container inside an applet, and inside the container I have placed few components, only the container changes, whereas the components in that never changes. So if I want to have set of components in one particular area, in one particular border, so then I can again load a container instead of loading those components or adding the components sequentially. So here we have also seen grid. If you want your columns, your components to be loaded in fashion of rows and columns, so in that case I can follow grid layout. And we have also seen what is grid bag layout. So grid bag layout will split your screen into rows and columns, that is your container into rows and columns, and these your components could occupy or could span multiple rows and multiple columns. So that is what is your advantage of your grid bag layout, whereas if you have more number of components to be added on it, and then it's very difficult to use your grid bag layout. So grid bag layout could be used in case if you have less number of components, and then also if you could split your components in proper rows and columns, we can go in for grid bag layout. So now we will have a short break and then we will proceed with how a grid bag layout is constructed for this particular program. Welcome after the break. So now we will proceed with how to create a application using a grid bag layout. So you can see here we have grid bag layout and we use JFrame here. This is the swing component. So you know JFrame, in your JFrame you cannot add components directly, and we need content pane in order to add components onto the JFrame. If it is frame, I can directly add the components, whereas if it is a JFrame, I need to get the reference of the J content pane, that is the base or default panel available on the frame, and then only I need to add the content. So then only I can set the layout. So you can see here container CP is equal to frame.getContentPane. So here I have used as container. So this is in generic. So this is not, I have never specified this as a J panel, whereas here I have specified this as a container. So this is generic. You know, this is what similar to that of your typecasting. So casting your derived class to a base class. So container is a base class, whereas your panel, your pane is a derived class. So I am mapping this and then I am setting the layout so to be grid bag layout. So here in your grid bag layout, I have not specified any parameters, you can notice, and then we move on to next. So here I am constructing a string array which is going to hold a string, a list of fields. So field names, I am going to specify last name, first name, country, email address, landline, mobile, cell phone numbers. So all these are stored in the string array field names. Then I have an other array which is an integer array which is going to hold the widths of these particular fields that I am going to have. So here you can notice that I don't have separate components being defined. So I have an array. Using this array, I am going to construct a set of components. You can keep in mind that we have a field names and you have field widths decided, and here you have the grid bag constraints. So we have already seen while we have discussed about grid bag layout, you can set up constraints for each and every component, or we can set a constraint which is common to many components. So whenever I add the components on the grid bag layout, these components will be added along with the constraint as the parameter. So that component will be added on that particular grid based on the constraints that I have set. So we have seen many properties such as fill, your grid x position, grid y position, your weight x, weight y, all these, so which are used in order to place your components in a particular position on that particular grid, or even you can say that as a display area. So here I am constructing a grid bag constraint. So I am specifying, first I am starting with each and every component that I am going to add. So grid bag constraint dot grid width. So this is assigned with a variable. So grid bag constraint dot reminder. So you know that whenever I say reminder, this is going to occupy. This is going to occupy the reminder position. So already if we have some elements, so this is going to occupy the next half or the later half of the row. Next is grid bag constraint dot anchor. Anchor, so it means that your component is not exactly placed to the size, and this will be anchored to any one of the position. It may be anchored to left, right. So it is like justification of your component on that display area. So we have a display area, and in the display area I am trying to place my components in which position, whether it may be center, left, right. So normally like in container we are going to place our components in any one of the border, north, west, east. So similar to that, here you can place a component in the display area using some of the fashion, that is you say anchor. So next I am setting the insets. So inset is the top, bottom, left and right pixels which could be used in order to position your object. So this is inset, the space between your particular component and that of your display area. So your display area, as I told you, is split into rows and columns. So in that particular display area, your component will be placed with this particular inset. So 20, 0, 15 and 0. So this will give you top, bottom, left and right space that should be available in order to place your component. So now I am giving a label as the input as well as a grid bag constraint. So with this constraint, I am adding it on the content pane. So next, you can see that anchor. So I am changing the grid bag constraint. So now I have added one particular component with all these information being set. Next, I am placing in other component. For that, I need to have other constraints. So I say grid bag constraints dot west. All these components will be aligned towards its left. So now you can see insets. I am setting insets 5, 10, 10 and 10 for this particular component that is to be added next. So here, for int I is equal to 0, I less than field names dot length. So I am going to access all the fields, so the field array. So I may have I here have more number of fields. So you can see here, for each of the fields I am specifying the grid width. So this is relative grid width. So then I am adding the j label with a label with the field name of I. So 0th label for last name. Next, for first label, first name. So similarly, I can add all the components. Next, I am specifying the grid width as a reminder. So here, reminder will occupy the last position and relative will occupy the previous position of whatever you have specified for the reminder. So now I will have one label and one text field with this field name, and text field is constructed with this field width with this particular grid bag constraint. So for all the components in the label, we have the field name array as the label and then your grid bag constraints of relative, whereas here grid bag constraints dot reminder is set to all the text fields with the particular width array of integers. So now I am packing my frame. So it means that I am organizing my frame with jam packed of all the components. So frame dot set default close operation. So in order to close your frame, I have default set operation and then I am setting my frame to be visible. Now you can notice here we have, so this is the labels that I have added and this is the text fields that I have added, and then I have specified the west position. So this is west, and then we have insets being specified and this is packed. So whenever I say pack, whenever I try to resize my particular frame, here you can notice that this will occupy the center position, whereas the frame only gets increased, frame size gets, whereas you have seen in your previous example, all the components are resized according to the resize that you make to the particular frame or applet. So next is about layout. So now so far what I have told you is about grid bag layout, which is one central layout applied for the entire frame. Whereas here, in case if I have more number of components and each of them has to be placed in different fashion, so in that case I can follow different layouts on one particular container. So you can see here we have a customer frame. This customer frame is going to hold more number of components. So customer number, customer name, address, display. For this I have labels, and then again for the same purpose I have text fields also. Next, I have two buttons, save and show button, and then here I have few panels. One is I have input panel, and the other one I have another panel in which I specify the buttons, all the operation panels, and then another panel called display panel. So now I am having a constructor for my customer frame. So inside the constructor, I am constructing the labels, and then I am constructing the text fields. After I construct my labels and text fields, I am specifying a layout for my input panel. So the input panel is going to have a grid layout. This grid layout is going to have 3 rows and 2 columns with an horizontal and vertical spacing to be 25. And then I am adding the components on the input panel. So all the text fields and all the labels are going to be added. So I add the label text field in all the combination. After this, I am trying to have a display text and other text area of size 25 150. So here I am constructing another panel. So in this panel I am specifying that 1 row and 2 columns. So here this 1 row and 2 columns means that I am going to have a new panel which is going to be attached to your previous panel. So this panel is going to occupy 2 elements, one is display label and display text. Next I am going to specify buttons. So 2 buttons I have specified, and then I am having a flow layout for the button, and then I am adding 2 buttons on that particular operation panel. So now all my panels are ready. Now I need to place these panels on my frame. So you can see here, now only I am calling this set layout method. This is for my frame. So new grid layout 3, 1. So 3 rows and 1 column. So this 3 rows are nothing but my 3 different panels. So my input panel, my display panel, and so I am adding in this fashion. Though I have created them in different fashion, I am adding them. First I need to have input panel, then display panel, and then my operation panel. So you can see that whenever I execute this using this main method, I am constructing the frame, setting the size of the frame, setting the location, and then I am making it to be visible. So now you can see that the frame has customer number. So this is one particular panel, this is one panel, and this is one panel. This is INP panel, this is your disk panel, and this is your operation panel. So this follows flow layout, this follows a grid layout, and this follows a grid layout. So here you can see that when this is again a text area, this is again a text area. While constructing these 2 text areas, I have used approximately the same size for these text area, whereas when I place them, right, whenever I place them, here you can notice that I have just constructed the grid, whereas here I have constructed the grid with horizontal and vertical positioning. So in that case my text area is not displayed entirely because this does not occupy the entire space, and since I have specified the inset, so here I have my size to be less and here I have it to be more. So based on how you have to display your components, you can increase the horizontal spacing, vertical spacing, and you can place the components and so on. So from this session, right, we discussed upon how to access the screen size and place your components based on the particular screen, irrespective of the screen size, placing the components relatively, and next how to have fonts being defined in your applet, and we have seen how to add components in an applet and how to construct a grid bag layout, and you have seen how various layouts could be organized on one particular GUI container or a frame or an applet. And from this session you will be able to answer questions such as how screen size could be accessed, how a font set in applets, how are arguments accessed, what is inset in grid bag layout, how to organize the contents using panels. So in your next session we will be discussing about how event listeners are handled and in what fashion we need to develop an application using the event listeners, and about adapters also. Thank you.